We now move to the next, Brian Aldridge, University of Illinois. Thank you very much.
Good morning. Another redhead. So another redhead up to speak to you. I've got red hair. Isn't it red hair? You don't think I've got... Lovely to be here. Thank you for coming. I love seeing many people jammed into this room. That just shows, I think, that growing appreciation of the importance of young stock in our herd and productivity. I also want to help you, I want to turn you into ecologists today. So I'm going to talk about colostrum and a growing area of interest in colostrum, which you might not have heard about, and really a growing area of interest in gut health, both in human and veterinary medicine. And that's really looking at the microbiome and the microbiological populations. And this has really been driven by sort of disruptive technologies that have helped us understand a really complex ecosystem and the implications of that for health. So I would have put this at the top if I realized how difficult it is to see at the back, to see the bottom of the slide. So I want to know what you think is the farmer's biggest obstacle to health and productivity in animals. I'm not asking for questions, but most people think it's pathogens. Most people think it's pathogens. And actually it's not. We have immune systems, and our animals have immune systems, right? So it's not pathogens, it's the phenotype of the animal. And that's what we do, and that's kind of some of the talks this morning have spoken about the phenotype. Dr. Sheila McGurk has shown that most days of diarrhea, for instance, in calves, are not caused by pathogens. They're caused by nutritional changes and poor milk replacer mixing and things. So what we're trying to do is we're trying to determine the phenotype of the animal. That's how the animal interacts, the genetics of the animal interact with the environment. And that's one big thing that we can change, right? We can change the genotype. We can do breeding and genetics. I don't like theriogenology or reproduction. So I think the environment's much more important than the genetics. But really, with the phenotype, they come together. So what we do as vets, how we can prevent disease is by managing that phenotype. And you see the best farms manage the phenotype of the animal best. They have the best health status, the best productivity. You know that your best managers, as already been said, are the ones who are managing that phenotype the best. So how do you think we do that? Where are the major sites, the major anatomic sites for phenotypic determination? I would contend that it's actually at the mucosal sites. The mucosal sites is where the animals have the biggest interaction with the environment. Certainly there's visual and auditory stressors, but if you think about the biggest exposure to the environment, to the DNA in the environment, certainly of the immune system, it's at mucosal sites. And most of the disease that you see are at mucosal sites. GI disease, respiratory disease, skin disease. We are really mucosal clinicians, if we think about it. So what happens at the mucosa determines the phenotype. And this is the sort of new dogma that's really being talked a lot about in mucosal surfaces. It's the interaction of the immune system at those mucosal surfaces with the epithelium at those mucosal surfaces, with the microbes at those mucosal surfaces. And what scientists are finding there's this amazing crosstalk. Each one affects every other one. The epithelial affects the microbes affect the epithelium, they both affect the immune system affects both of those. And that makes sense. And really what disease is a failure of homeostasis of one of those things. So if you can get that right in your animals, you don't need to be afraid of pathogens. So we teach a lot to our students about evaluating mucosal health, whether it's respiratory disease, whether it's skin disease, whether it's GI disease, and thinking about that as in managing the phenotype. So if you want your calves to move forward, we know that the indicators of the phenotype of those growing animals before weaning are really good indicators of first lactation milk yields, second lactation milk yields. There's been some really good work looking at the day an animal takes a kilo of food, weight gain, as we just sort of said. There's phenotypic indicators that are actually determine and give you pointers as to how that animal's going to do, and even in first and second lactation. So if you want your calf to move forward, you've got to manage that phenotype well, particularly in that pre-weaning stage. We know colostrum's important. We all know colostrum's important, and colostrum management comes out again and again as the most important factor. So But I want to show you how the colostrum affects that mucosal surface rather than this systemic effect that we think is important for colostrum, and it certainly is. So that's what we think. We think of colostrum as squeaky clean. There's a lot of work talking about the bad bit of microbes, making sure you refrigerate colostrum and do cleanly. But we think of it as little packages of antibody. It's much, much more than that. And it's not as squeaky clean as you think it is. You think it is. There's been a lot of work in humans looking at the benefit that actually milk, before it comes out, has bacteria. That's scary, isn't it? It's not as clean as we think it is. There is a microbial population. With the new technologies of deep sequencing, we're finding that what we thought were previously aseptic sterile sites are not at all. They're actually ecosystems, and that those bacteria play a really important role in educating and maintaining the immune system in a inflammatory ready, not pro-inflammatory, but ready to respond. Without those microbes, the immune system in those mucosal sites doesn't develop as well. So that work's been done in humans, hasn't really been done in our animals very much at all. This is a diagram showing the amount of microbes, the concentration of bacteria over time. Last third of pregnancy, it goes up. Peripartum, breastfeeding goes down, and then weaning, it drops off. So that's under hormonal control, blood flow control. There's a number of different things that control the microbial population in breast milk. So that's why those of you who are breastfed, you're so well, you're so good, because of the microbes. It's because So our study hypothesis was that colostral microbial communities contribute to the gastrointestinal microbiome of the young calf. So what we did was we standardized. We worked on a dairy which has 32,000 dairy cows. We tried to standardize the dams. We got all second lactation mothers. So it was a single farm. We snatched the calves. We didn't let them touch the ground. We sterilized the udder. We milked out the udder using a sterile technique, catching it to sterile bottles. And we made sure it was high quality by using a Brix refractometer. We fed them from sterile bottles and sterile teats. We then put them into a sort of a high comfort situation. We didn't clean it out too much during the time. We got good workers. We got female workers to work it. So I knew what you were going to say today already, right? So we put them in high comfort, the 5 C's, optimal feeding. And then we monitored their health, and at different times we euthanized them, and we collected a whole range of samples. So this is what the kind of samples we collected. We did let mum lick the calf just for welfare reasons. We let some bonding, even though we caught it. We took it round to the head as we collected the milk. We collected samples from the udder, even though they didn't suck. We collected samples from the vaginal tract, because that's been shown to contribute to the microbiome. We took colostral samples, and we took fecal samples during the calf's life. We then necropsied, we did 12 calves, we necropsied calves, 3 calves at 4 time points, day 1, day 3, day 7, day 21. And we took mucosal samples and scrapings as well as luminal samples from various GI sites during that period of time. So we're comparing those different calves. This is just sort of the technological aspect, and you might have heard of this in some of the microbiome. I didn't do this. We have some clever people on campus who do this sort of sequencing using the 16S RNA gene. They get 2.5 million sequences, 1.5 million unique ones, identifying 1,000 different bacteria. And guess how much it costs per sample? About $20. About $20. So cheaper than culturing, amazingly. So that's why it's become so accessible. So this is kind of some of the graphs that you'll see. What they do is they kind of line up the sequences. They don't call them all by name. They align them into what are called OTUs, operational taxonomic units, which are really just sequences that are similar to each other. And then they work out how closely related are those sequences to each other, how different are they, for instance, at different parts of the intestine, how different are they, and how different things contribute. How did colostrum contribute to that? How did the vaginal tract contribute to that? So that's kind of some of the graphs that I've tried to summarize a little bit, and just for those geeks around you, that's kind of what we did down there. So here's just a few. I've just highlighted really 4, 5 points from this. Maternal, upper GI, and lower GI microbial communities are different, but they overlap with each other. So this is the maternal one is here. These are all the maternal samples. This is the upper GI, that's the lower GI. I just want to show you that too. It's not just a bunch of bacteria. You start to see an ecosystem developing, and they overlap. That's a little bit of a clue as to where those microbes come from. So they are distinct, but they overlap from with each other. This is the sort of picture. These are all the samples down here, the different biogeographical locations, different intestinal parts. These are the days. I just want to show you kind of the diversity. And when you look at an ecosystem, do you want a diverse ecosystem or a narrow ecosystem? You want a diverse ecosystem, right? That's an ecological principle. And we think in disease, we've done some work on some diseased animals, some preliminary work, and we see we lose some of this diversity. I'm going to break this down just a little bit for you. And these are all the species. So every species has a different color. But you can kind of see, start to see patterns in there as well that the bioinformatics brings out. So here's the difference. The luminal and mucosal communities are different from one another. Do we care? Yes, we do. The ones in the lumen contribute to digestion. The ones attached to the mucosa are the ones talking to the immune system and to the epithelium. So you can see, if you just look at these patterns, they look very different. So it's not just a bunch of bugs. There is an establishing population that are attaching and becoming part of the mucosa. This shows how they change over time, and the diversity changes over time. This is the scrapings, this is the mucosa. These were all over the place. You can see there are distinct patterns and changes at certain time points, and certain sites develop an increase in diversity over time. So we see, again, the slow establishment over 3 weeks. What we do to this animal in those 3 weeks is important for how its microbiome is developing. This shows the contribution of different maternal species. So the colostrum contributed hugely to the jejunum and the ileum. The maternal vagina, the birth canal, contributed to the duodenum and proximal jejunum. The udder, which it didn't touch, contributed to the abomasum. And all of them were found in the feces. So you see how the different parts from the mum contribute in different ways. The mucosal microbials more closely resemble maternal microbial communities. So these, day 1, day 3, day 7 to 21, they became more maternal as they went on. So that means it just took a time for those maternal communities to actually get established. It wasn't like day 1 or hour 1. It took 2 or 3 weeks for them to look like mum. And interestingly, we also found there's also interest in microbiome as markers, not in determinants of health, but also markers of health. So this where we found that there were different bacteria, and this is just early work, that were actually linked to weight gain. So people have found, for instance, certain bacterial species that are related to colon cancer. It's not a cause of colon cancer, but the colon cancer allows that proliferation. So there might be markers of health as well. So the executive summary for you all is that colostrum is more than an antibody meal, and the colostrum microbial communities contribute to calf mucosal microbiome. And the healthy calf intestinal microbiome is unique, but seemingly a stable ecosystem. All these were healthy calves, and everything that we could do was standardized. So we haven't looked at milk replacers. So how does that affect immunological and activation of epithelial health? We're developing some assays to compare that. So we're trying to link those three to look at all of that triad. That's going to be future work for us. So just the implications. What's the influence of mucosal microbiome on health and productivity? We don't quite know, but I think there's some interesting work to do that. I hate to see the people who eat yogurt are right, but it's true. How does this inform our colostrum management? What about freezing? What about using colostrum from one cow to another cow? How does that affect with that? Pasteurization, there's lots of things to think about that. And how can we manipulate that neonatal phenotype through the mucosal ecosystem? I'll be glad to answer any questions.
Thank you very much, Brian, for the excellent and challenging presentation. Is there already a question there?
Hi, Rachel Brown from Ireland.
Hi, Rachel.
You were looking at the different microbiomes, including vaginal. What about C-section calves? Because I think I read something about in C-section babies.
Yeah. Yeah, Rachel, you're exactly right. So they've shown that if they, we also looked at respiratory. We haven't published the respiratory, but what's happening in the respiratory tract as well. But in humans, they found that C-section babies are different than vaginally born babies. So we're going to have a look at that as well. But I think that would be really interesting as well. So I think it's a great question. But that's been shown in other species, yes.
Yes. Yeah, just wait for a mic.
Congratulations.
Come here.
A fairly obvious question that comes out of this is with antimicrobial use, and there are lots of instances where we're using antibiotics in the first week of life, and sometimes we're using them in a metaphylactic sense.
Yeah.
Where's this going to lead us?
Yeah, no, great question. And part of the driver is about antibiotics. So a couple of things there. What we hope is that by understanding this ecosystem, that can we manage it better and hopefully reduce the use of antimicrobials. We have done some work in pigs where we give single injections of antibiotics to healthy pigs. It's amazing the change, and we did fecal microbiomes, how they change. And different antibiotics change them to different degrees and for different lengths of time. So we'd see in day 21 that the fecal microbiome hadn't restored back to normal for at least half of those antibiotics. So it does, it massively impacts it. I don't know what effect that is on health and production yet, but yes, it has an impact certainly. Great question.
Yeah.
Carlos from Spain. Congratulations for the conference.
Thank you.
One question. In your opinion, what is the role in the different management now that pasteurized colostrum or pasteurized the milk for feeding the calves? Thank you.
Yeah, our next study, we're going to do some calves with milk replacer, and we're going to do them with pasteurized colostrum. So I think that's a really interesting, we tend to just, all of our colostrum management has been based on antibodies, not on the idea of mucosal microbial communities. So I think there's some more work to come. I think it will have implications for those things as well. You obviously don't want too many bugs. We sterilely collected these, which was important as well.
If it's
Hi.
5 seconds and 5 seconds answer, because we have to...
Okay. Marcio Costa from Brazil. Have you looked at any correlation between the quality of colostrum and the kind of population of bacteria there?
Yeah, we did serum antibodies on them. The colostrum quality was all very, very high colostrum. So beyond the bricks, we didn't do a close correlation between those two things. The colostrum populations were really quite close to each other, amazingly, as were the calves. The calves weren't really different. There was some similarity as well. It's quite a stable ecosystem.
Thank you very much, Brian.
Thank you.
I'm sorry, we have to move. Thank you very much.